morning, everybody, for joining me, and thanks to Steve and thanks to the Technology Council and the college for your posting. Appreciate it. Appreciate the opportunity to be here. I'm going to talk a little bit today, share some insights on electric vehicle charging and electric vehicle charging infrastructure, which is behind the scenes of the technology behind the power delivery mechanisms and different chargers. So along with my partners, Mike Gorman and Chris Angelo, I'm one of the founders of EVKON. We're an electric vehicle consulting infrastructure solutions company. So we're less into the cars and we're more into the how do we get the energy from the grid to the cars. So a little background about myself. I'm a multiple business owner. I've been self-employed since I was 14, so I've never worked for anybody since the camper cow. I was 14 years old. And I currently own the Nines Art Gallery. It's an art gallery in Harwichport with my lovely wife. We have children, 2 girls, 16 and 17, and a 3-year-old boy, and another one coming in November. So I was an offshore commercial fisherman for 30 years. And I did all kinds of stuff on the boat. I learned a lot about diesel mechanics, how to operate, how to be self-sustainable on water, basically how to figure things out. I have the Chatham Harvester Seafood Cooperative founder, board of directors on that. We sell locally sourced seafood that's day old out of Chatham, and sustainability and traceability. So the environmental stewardship is an important component of what I wanted to do next to me. I also wanted to be able to figure things out and solve some problems. And one of the things that I like most about this electric vehicle charger industry is that we're solving problems that have not yet been solved before. Stuff we can't look up on YouTube, because there really aren't any answers. We know Europe is doing some things. They're on a different grid system. They 220 across the board, so we have a little bit different challenges there. California is doing some things. They have a different policy scenario than we do in a lot of places. So with all this background, we started EVKON about 2 years ago. We are electric vehicle charging infrastructure solutions company, which is a mouthful, but basically that means figure out how to get the energy to the car. And there's a lot of stuff that goes into that. There's a lot of technology that goes into that. And what we do is design large-scale commercial installations for charging systems. So this is not residential stuff. We don't do any of those. There's a demand for that. Charging at home is very important. Charging away from home is the fill-in for when you can't charge at home. Down in the Cape especially, there's a lot of people coming in from off-Cape, summer visitors, weekly stays. These people might have chargers at home. They don't have chargers necessarily at the rental houses down here. So we need commercial chargers to be available to refill these EVs that are coming in from off-Cape. More and more people are adopting from on-Cape, and so we have to have destination charging around. Our current projects are, we have about 30 projects right now actively. With auto dealerships, putting in DC fast chargers for Ford dealerships throughout New England, New Hampshire, Connecticut. We have some large-scale resorts. The resorts are interesting. They're putting in their chargers at multiple sites within the large resorts. So they'll put them in the reception lot. They'll put another bank in at the pool and tennis court area. They'll put another bank in at the restaurant. We have some retail establishments. The retail is looking to drive not only charging revenue, but to drive additional retail revenue by providing an amenity that people can come, plug in, stay for a little while, and shop and increase the residence time at the store. We also have multi-unit dwellings, some municipal stuff, which we can talk about. The municipal is a difficult use case right now. Multi-unit dwellings are apartment complexes, putting in charges for the people who have EVs that live in apartment complexes. They have a problem because the EV owners are renters. The renters don't control the properties. So the owners have to be persuaded to put these amenities in for their clients. We also have some larger parking garages. We're working with one of the largest parking operators in North America. They have a portfolio of parking garages, and we're starting in downtown Boston. We are putting in 60 chargers on a parking garage in Boston, 6-story open parking garage with multiple floors, with multiple chargers on each floor. DC fast chargers going in there. We actually doubled the power capacity of the garage that we got from the utility, so we were able to increase the number of chargers on that site by double. The next project for that is a 8-story parking garage in Hoboken, New Jersey. Phase one for that will be 20 level 2 ports, and we're going to be bringing in 3 megs of additional power to put in a giant first floor, complete 15 DC fast charger project with some additional level 2s. They're looking to supply the city of Hoboken, and not just the residents of the nearby apartment buildings, but also the rideshare services. So you have Hertz and Avis converting their fleets to electric vehicles. In the city, they need someplace to park. They park in these parking garages. They'll contract out an entire floor. So now they're able to provide charging as an amenity to their new rideshare arrangement. We have this scenario where we've got multiple different industries, multiple different industry verticals, all with different sets of need for chargers, for different reasons. So this is a little graph here about the increase in the demand of electric vehicles. You can see that back in 1920, we started increasing, the snowball started getting bigger and bigger here. The amount of chargers starts to increase. We've got about 5 million EVs on the road today in the United States, and in Massachusetts specifically, we have a 2% adoption rate. So we say adoption rate, and that means it's a measure of how many cars on the road today are EVs. So this is a cumulative number. We're 2% of all of the cars, which means that some of the internal combustion engines, which are ICE gas cars, these guys have been on the road for 10 years. So we're counting that in our percentage, how many EVs. But more significantly, the stat that we want to talk about is that in 2023, 12% of all the vehicles in Massachusetts sold were EVs. So while we have 2% of the total overall base, all the cars today, last year, 12% were purchased as EVs. So you can see that as that number is increasing, we're going to have more and more of the older ICE vehicles are going to become defunct and get taken off the road. And so we're seeing this increasing trend, and we have some projections here. And now the projections are anybody's guess, but the math scientists have decided that this curve is the most likely to happen. And the increased demand for these cars, and you ask why? We've got a couple of reasons. We've got cost of ownership is decreasing. As any new technology comes in, new manufacturers have to build auto plants. The auto plant investments need to come to fruition. Once the factories start producing more, the mass production bringing the cost down. We also have battery technology and cost decreasing, so we're getting more miles per unit of battery. We have more manufacturer models available. There's a techie demand where these cars are now seen as like kind of the new iPhone. People want to have the latest version of the newest technology, so there's a boost in demand there. We also have less range anxiety, which is a concern that many people driving electric vehicles have, that there's not going to be a charger when they need one. And as more chargers are being rolled out, more charging stations, the range anxiety is starting to diminish, which is unlocking the door for purchasing to more and more people. We also have policy incentives which are changing. New tax credits, new incentives to purchase. There's big funding right now in Massachusetts especially. Policy changes particularly, and I'm not sure who knows this, but many states have actively banned the sale of ICE vehicles after 2035. And Massachusetts adopted this law on the books in August of 2022. So they've promised the Commonwealth that no more gasoline cars will be sold after 2035. So regardless of your sort of political leanings, then we can put that to the side. We have a scenario where the active law is that no ICE vehicles. That leaves us with EVs. And our insights into the Ford and the other auto dealers have given us this awareness that the car manufacturers are shifting and the policymakers are shifting. The trend seems to be clear. You're going to have more EV cars. Massachusetts goal 35% by 2026, just in a couple of years. So that was 12 last year. So they're looking to basically triple that number in the next 3 years. So the challenge is the country and the region doesn't have the infrastructure to support this many new vehicles. infrastructure meaning chargers. So what we have is we create an electric vehicle charging system. We have an electrical infrastructure need for that. Electricity is complicated. We're going to have to talk a little bit about electricity. We'll get into some terms about electricity later. But basic knowledge, you've got what we used to call telephone poles that we now have to call utility poles. They're bringing in high voltage at the very top, the part that you can't touch. Super high voltage, the higher the voltage, the smaller the diameter line that can carry them. So we have an efficient way to deliver high voltage. Once you get to the source area, the target, you need a transformer. The transformer is a fancy term to get the voltage from being up here down to usable voltage. So if you ever looked up in the utility pole and you've seen those gray cans that are just sitting up there, those are transformers. There's a smaller version of transformers, usually the size to deliver electricity to usable electricity voltage to a neighborhood or something like that, or so maybe a business or two. We also have the big pad mount transformers, which are giant green boxes that convert lots of voltage into lots of usable voltage electricity. So we have two components here, which is the voltage capacity, but also the amount of energy that's being supplied. The amount of energy that's being supplied is dependent on the amount of energy that's put into the circuit. Much like your bathroom circuit in your house, how many hair dryers can you plug in? You got 3 or 4 outlets in there, but we can't plug 3 or 4 hair dryers into them because you're going to blow the circuit. So we have that from a neighborhood scale, and businesses especially have limits to the amount of energy that can be obtained from any given circuit. So if we bring the transformed energy onto somebody's property, we now have to have a couple more pieces of equipment. So first we want to meter that right there. We're going to create this independent system. Metering the energy into that EV system allows us to get on a friendly EV rates that are provided by the utility companies, discounted compared to your business electric bill, and also benefit from favorable demand charge reductions. Demand charge is something that most of us are you're probably not familiar with. Residential, you turn the lights on, it measures how long your lights are on and how many lights are on. You get charged a certain 25 cents a kilowatt hour. When you get into commercial applications, they charge you for the amount of energy that's available for you to take at any given moment. And they charge you monthly fee for the maximum amount that you take. With these new chargers that are consuming lots of electricity, you could theoretically turn 2 or 3 of them on for 1 hour for the entire month, and you'd be billed at the same demand charge as you would if you turned them on for 40 hours for that month. And you don't have the luxury of billing the client for that amount of charge. The next piece of equipment we have is the panel here. It's the distribution cabinet. The distribution cabinet is like an outside circuit breaker. Just like you have down in the basement of your house, you got all these branch circuits and circuit breaker switches, so we've got a big outdoor version of that. It's also on a pad mount. It's taking that high voltage electricity, and sometimes we can have a side transformer into it so that we can have DC and level 2. DC fast charging is operating on DC current at a higher voltage, and AC is the level 2 charger. So we have sites that are mixed. The distribution cabinet, which is showing a panel, is a very important piece of equipment because it allows us to dispense multiple voltages to multiple different charging stations that supply multiple different voltages. Then at the end, of course, we have the EV charger. So that's the device, the dispenser, the gas tank, the gas pump, if you will, and the chargers are all different. And then finally we get this energy into the electric vehicle. So most of this stuff is buried underground, and then you see the transformer is pad mounted, the meter is usually attached to either the transformer or the panel. There's a big transformer. This is about 4 feet by 5 feet by 7 feet, pad mounted. It's a 750 kVA transformer, which is about the size for a significant project with multiple DCs, multiple level 2s. We're converting the high voltage here to dispensable voltage levels. So in You gotta think the telephone pole's on this side, and we're coming in with a high voltage underground through conduits to the inside, and then we have the transforming is done. Basically, it's got loops of copper that use magnetism to transfer the energy without touching anything. The more loops you have on one side compared to the other, like a ratio, you can step the voltage up or down. In this case, we're usually stepping it down from 13,000 volts up top down to something like 480 or 220. That comes out from there. That's called the secondary. Primary in, high voltage, don't touch. It's in conduit. It's encased in cement, underground, buried 3 feet deep. I have some pictures of that later. Secondary comes out and goes to the distribution cap. Then it's the branch circuits. These are chargers. If anybody has any questions at any time, just jump in. Happy to answer or divert. So what we have here is a series of chargers. We have a distribution agreement with Autel. Autel is historically, they've been around for about 30 years. They're an automobile diagnostics equipment manufacturer. They produce the device that you plug into the car that tells you what's wrong with the car. They're highly into diagnostics, and there's many different versions of that device that are all throughout your auto repair shops. They branched into making EV charging stations. Many EV charging station companies around. Most of them are kind of built the product for this reason, that they need to dispense electricity. This company we find is excellent because of their software that backs up their product, and also their remote diagnostics, which is based on the company history. So here we have a couple of different chargers. We've got a DC. These are 3 DC fast chargers. You can see they're bigger, the hoses are bigger, thicker. This one, each of these is a different size charger. And when I say size, I'm talking about the physical size. I'm talking about the amount of energy that charger is capable of. Over here we have a level 2 that's on a pedestal. This is a level 2 that's a wall mount. And this is a new product, which is a V to G. It's a vehicle to grid. It's a charger that allows you to bring energy in from the grid, supply your car, and it also allows you to sell the energy back to the utility in reverse so that you can use energy as an arbitrage. So we don't have as much time of use here yet in Massachusetts, but during peak periods of high demand, places like California, they're charged a different rate during the day than they are at night. So if you have an extra amount of battery capacity remaining when you're finished using your car, you can send that back up to the grid, get an energy credit, and then that night when the power is cheaper, bring your power back to your car. It does it all automatically. So we talk about levels of chargers. We have level 1, level 2, and level 3. So level 1 is at your house. You've got the 110 outlets all over in the living room. You can plug in just the regular cord. That's 110 volts. So that's a level 1, home charging unit. Then we get into level 2, which is home and commercial. Level 2 is using 220 or 240. This is like your oven and your dryer. It's using 2 legs of 110 to bring twice as much energy in. So you get a bigger amount of energy that's able to be dispensed because your source is larger. And then we have level 3, which is DC fast charging. So the first 2 levels are AC, alternating current, like your house, and then DC allows us to go much higher. The voltage for DC is 480, so twice as much. So now we're going to talk a little bit about some mathematics. Everybody loves mathematics. So here we have our 120 volts and our 240 volts at home, and our 240 and our 480. And so what we use, the number that we're looking for here is kilowatts. Kilowatts is a measure of electric output. So we have watts and we have volts. We talked about volts. Watts is like the size of the pipe. Sorry, amps is like the size of the pipe. How much water can you dispense at any one time? The kilowatts is the measure of the output. So we're measuring how much energy can be dispensed at any given moment. So you can see with these lower voltages, we have small numbers here. 2.5 kilowatts is plugging in at your house, and that's why it took you 40 hours to charge your car, because we're only getting 7 miles per hour of charge. Every hour that that car is plugged in, we're only receiving 7 miles of range. And now, look, that's an average, because just like ICE vehicles, we have trucks that don't get as much gas mileage as we have cars. Same thing is with EV. So 3 miles per kilowatt hour is like an average amount of range. Then we double that power voltage up to 240, and now we can increase all the way up to 7 kilowatts. Now we're getting 20 miles per hour of charge. And so for a home charger, this is a nice thing, because that means that you can plug in overnight, and in the morning you'll be full. Most people, incidentally, are driving 30 or 40 miles a day. So they don't going to need to plug in even more than twice a week, potentially. This is a good option, though, to have at home over the first one, because in those times you need it, you can charge a little bit more quickly. The level 2 chargers that we set as our minimum standard are 19 kilowatts. These use 100 amp breakers. They're dedicated circuits. That gives us 60 miles per hour of charge. We use this especially in business circumstances, because people have to make a choice when we have an EV. We have to talk about whether it's worthwhile to get the cord out and plug in and do the interface with the machine, or pay for it. And if you're going into Dunkin' Donuts to grab a coffee for 5 minutes, when you're going to go back to your car, it's not going to be worth your time, because you're going to have to go through all that work, and you're only going to get a certain amount of charges out of it. So we start talking about, well, what is the site and what is the application? What is the use case? What is the dwell time? What is the residence type? Why are people there? Are we putting chargers in a place that has nothing to do, like the park and ride on exit 10 as chargers? You know what you can do while you're there? Read the newspaper. Wait. They have 7 kilowatt chargers, so you can be waiting a long time. Now, of course, you can get on the bus and go somewhere fun, or your wife could drop you off, and you can get free charging there while you're at home. If that happens, people are always trying to get around the things. They're trying to get free energy wherever they can, because we're in a world now where all of a sudden you can have your own charger, which means you're your own gas station. You could never be your own gas station before this. You can't get petroleum out of the ground, but now you can get energy out of the sky from the sun. You can put solar panels in, and now you can have free energy that you're putting in your gas and cut your gas bill out completely. That's an attractive thing to people. We put the 19s into places such as retail areas. We'll put them, this is a good candidate for a municipal downtown parking lot. The reason is, you're going to go there for an hour or two, maybe you get your hair cut, maybe you go over to the hot stove and get a cheeseburger, maybe you have a dessert instead. Well, you're looking at your phone, you can tell how much power you have left to go in the battery. And it gives people a reason to stay for a little bit longer, but it also provides them as a destination when they're planning their day. I'm going to go get a charge while I'm going to do my errand on this or that. So having the chargers placed strategically for certain reasons is a good thing. And when can we put in a DC fast charge? Well, that's when the residence time wants to be 20 minutes or less. So of course, highways. Pulling off the highway, everybody just wants to use the facilities and continue on their way as fast as possible. And in 25 minutes, we can fill up a car with a DC fast charger of these ones. You see, this is about 10 times as fast right here. Here's a level 2 station. And our fearless intern this summer, Nick. What we're seeing here is a 19.2 level 2 charging station. This is a pedestal mount. And you saw the wall mount in the earlier slide. This is a dual port, which means that there are 2 hoses and 2 dispensers. So we put this in the center of a parking line, and we have 1 car on the left and 1 car on the right, servicing 2 vehicles. This also has some protective safety bollards. You can see it has a cable management up on the top here, this tall part. There's a retractable cord that's attached to that circular ball at the top. So when you pull the cord out, plug it into your car, it comes out nice and easy. It doesn't drag the hose across the ground, and it goes back up, and you don't have to fumble around with a hose reel to put it away. Let's see what else does this have. It's got a credit card reader right there. And it has a digital screen. The digital screen will show you how much energy you're using, the price of the charge, and it shows you, oh, what else do we see on that screen? I think you put advertisements in it. It's kind of in its infancy, but especially with the DC fast chargers, which you'll see in a minute, we can put some either site or off-site advertisements. The payment is done through those devices. QR codes. Here is a fast charger. So this guy's pretty big and beefy. I'm probably looking at about some like a refrigerator box. Maybe not so tall. Big digital touch screen. You can play videos. People are selling advertising space on these so that the people are standing there dispensing their car and advertisements are showing up.
What's the cost of one of those?
Cost of these is all different sizes. See the second line there, 120 to 240? So you can also, the first slide when I showed the whole section of it, the lowest DC that you can get your hands on right now is about a 40 kilowatt. So we're 2x the velocity of this. So we get into that DC, those costs of the manufacturer is probably about $20,000. We go with this model, it goes all the way up to 240. That's probably somewhere in the neighborhood of $120,000. We go back to this one. This is the 480 kilowatt model. It's deeper than it looks there. That guy is brand new. I'm not even sure, but it's probably going to be $200,000.
Quick question, is that the price is that what it's equivalent or is that installed?
Just that piece part of it.
And what's the cost of the same?
Let me get to the design part of that, because I have I've got that question answered in a very long-winded way. Okay, back here. So the other thing that this has is that we see that this cabinet houses 120 kilowatts DC, so that's going to dispense it at our 120 kilowatt velocity, which may be appropriate right now because cars have onboard charging limitations where some of the cars can't accept a 240 kilowatt charge. But we're all aware that the battery technology is improving, the onboard diagnostics are improving. We're going to be able to take more charge at a higher rate when the battery tech increases. So these chargers are nice because they're modular. They have 20 kilowatt power modules, so we can put in a 180 or a 120, and then later we can add power modules to bring that charger up so that we're essentially future-proofing and protecting ourselves from wasting an investment when technology changes. The circuit breakers have the same ability. This is going to take a 300 amp breaker in that panel box. There's a new type of ratcheting breakers called dynamic breakers that you can set them for 200 amps to start out with, and then instead of taking that breaker out, throwing it away and getting a 250 or a 300, you can adjust them. So we put in the infrastructure of the below ground wiring with the capacity of the highest end that we think we're going to use, and then adjust the breaker down to keep protection. These are all ground fault protected. These drop the hoses in the water. More questions on chargers? Get into some.
Is there a standard connector now?
Yeah, so that's like in flux. Tesla had their charger that was only their port. It's the pin orientation on the dispenser nozzle. And Tesla had a proprietary because they wanted to use anybody to get Teslas in the Tesla network. So once Tesla had put in enough chargers to start this adoption and start the snowball running, they decided, well, let's open up that network. And everybody was a little surprised that they said they're going to slow down their supercharger network deployment. But really what they know is that now other people are putting in more chargers. Let's make sure that our connectors are equivalent, and then we'll put in all different brands of chargers and everybody up there. So right now there's an adapter that goes on the nozzle, and any car can charge out of it.
These also have fault protection.
Yes. Yep. Internal on board on the machine, so that it's like a safety function. In addition to the breaker being protected in that way, so it's like a redundancy. big hoses, big nozzles. So now we have to have some software. Software is going to be the brains behind this machine because it's complicated. We're going to have to deliver energy to the car, and we need to do it in a safe way. So the charger does a couple of different things. It monitors all the energy dispensed. It keeps track of it. The retail applications for this are, there is a charging margin, which is by what some of the attractiveness of this as a business. You are purchasing electricity at 25 cents a kilowatt, and market price right now for level 2 chargers is about 40 or 45 cents per kilowatt. So you have a margin there. Software is the point of sale system. It collects the credit card information. It uses a QR code. A lot of people have apps. If you own a car, you have an app. A lot of the apps are roaming, which means that the different chargers have different apps, but they're all be able to be used on any given machine. So you go up, you either tap your card, or you put your phone up there, and you hook up with your app. And now even that's about to change. In about 6 to 12 months, they expect the car is going to be input with your payments structure. Put your credit card into your automobile computer, and when the hose is plugged in, it reads the car, and then it automatically applies the sale without having to do any credit card.
Is that going to be just for new cars, or are they going to retrofit all the existing?
They should be able to retrofit it because all the software that's on board is able to receive updates. And what we may have to do is update the cables from the chargers. So the technology has to be inside the cable as well. And so there's the hotels in preparations to be supplying the replacement cables. So the software also has to deal with the merchant pit services, just like at a regular retail business. Somebody's got to pay their credit card people. And part of the funding that's available right now requires monthly reporting. The entities that are providing the funding are interested to know the utilization. So as a deal of receiving the funds, you agree to supply reports of how much charging you provided over the previous month. Let's see if I have should here. Here's just a dashboard that somebody might have, and just a quick, easy look at all of it. You can have all of your different charges. You can have multiple different sites. This is telling us how much revenue you have this year so far, this month, how many sessions you provided, any faults that happened and when they happened, at which charger, the energy consumption, how many people used it, and how many, this will show how many available charges you have right now. And if anybody's in use, you can drill down into them and see what your charge is being dispensed to who, for how long, and how much you ended up using. So we've got this revenue capturing organization device. And the other valuable part here is the remote diagnostics. In the DC fast charging especially, they've got many internal components, but the Autel software maintenance platform is linked. They have 300 different touch points in there where the software knows remotely what those parts, what the status of those parts are in real time. All the chargers are hooked up to either cell, Wi-Fi, Ethernet, and they can be tokenized if there's no internet connectivity. That means that every X amount of minutes, there's a connection made, and it sends an update status back to the dashboard of the owner. So we know who's been charging and all that, but we also know if there's any problems. And we know it's in real time. And that ability has, we can do remote troubleshooting as well. We can do system restarts. It's kind of like the IT ability to get on your laptop remotely and fix stuff when you're not there. So this contributes to uptime. Nobody wants a down charger. Nobody wants to drive off the highway thinking that they've got 10 miles to go and they've got their charger in their sites and it looks empty and vacant and available, and they pull up and it doesn't work. So charger uptime is very important to the health of our industry. Ability to do remote diagnostics is very helpful to keep that up in the 98, 99 percentile.
Can you explain tokenize?
Not very well. But I'll give it a shot. So there's a company called Zeal, Xeal. Their entire platform is based on the tokenizing because they're trying to target a niche where there's no or limited Wi-Fi cell connectivity. Parking garages, for example, subterranean parking areas. So you're going to have to put in hardwired, which can be very expensive to Ethernet down. You're also relying on somebody's router system, which could become either compromised or unplugged by accident. And we're talking about people needing the ability to make charging, but they want their charge, but they also need to pay for it. And paying for it is the first step to unlocking the charger. A lot of times you can't even withdraw that dispenser nozzle until you put your payment mechanism in, and then at the end it closes you out. You put your nozzle. So the tokenized reader creates a digital token of the charge, and it keeps this in. It's like what's the Bitcoin term? The blockchain. It sets it up in this historical record, and then the next user comes in and they use it, and their blockchain continues, and they added a new token. Token meaning a snapshot of that particular event. So now this person had their token and it went onto the blockchain. Now my token went onto the blockchain, and then I left with my phone and I went back up into the sunlight and I received cell signal again, and it sent it back up to the cloud where they received the tokens and download the information. And the ability to do that across multiple users creates a redundancy. Okay. Got that?
Just stretching redundant. Does that apply to just the chargers, or does it apply to full diamond?
Their whole industry that they pioneered before is like devices that check to see if your catalytic converter is broken and for what reason. Oxygen sensor, plug it under the, yes, all of that stuff. And commercial grade stuff too, not just the little computer that plugs in under the dash. Yeah. The stuff that's supporting the back end repair. So their company history is based on that, and so they've built that into the back end of their EV products as well.
Should that be on the supplier side, or would that benefit the consumer and paying the car has an issue?
It's not about the cars here.
Just charge.
It's just they have that for the cars, but that's going to be through the repair place. They have this also inside the hardware, but the value to the consumer here is to the owner of the hardware. So it's like this: my charger doesn't work. Okay, I don't have vision into the remote diagnostics. What do? Well, I send my guy out there, and he goes out and he opens it up and he sees what the problem is. And then he sees the part that he needs. So either he has to have the part on the truck, or he has to drive back to the inventory supply house and get the part, then he has to go back over it. Whereas if you have this remote diagnostics, you can see that it was part number 17. I'm just going to bring it with me, and I only have to go once. So I've minimized repair time, I've reduced cost of repair, and I've maximized the uptime because that guy can just fix it as soon as he gets there rather than going back. That's the value of the remote diagnostics. Another cool thing that this software has now is smart charging. So we have a dynamic load balancing and an adaptive load balancing. So dynamic is a little bit easier to understand, but a certain amount of energy that you can have from the utility. But the first thing we do in these applications is ask the utility, how much power can we have? They're not going to give you every little last bit of power on the circuit because maybe a new building is going to go in next door. They have to save some for the vacant spots. But the utility is also in the business of dispensing energy and selling it, so they want unused energy to be utilized and transacted so that they can sell it and make money on it. So they want as much power to be used as possible. So the first thing that we come up with our applications is how much energy do we get for the site? And so we take this initial number, and in this case, this use case, they've given us 44 kilowatts, which is a small one, but the dynamic load balancing allows the two automobiles to split that charge. So both of them are maxed out at half, and the software allows us to go in there and we can set priority users and where this guy never gets depleted. That's the boss's spot. If boss ever parks in here and gets 100%, and the other guy gets whatever is left. Most of the time, it's shared. Then we can get into an adaptive load where this measures the amount that the building itself is using. So if it's the evening time and the lights are on, there's not as much energy on the site to go around. So they share that, and the smart charger knows in the software how much energy can be delivered safely without blowing the break. So this adaptive load we're not using as much right now because all the systems that we're putting in are independent. We're not bringing off house power. We can bring off house power, but we want our systems to be separately metered because the cost of the energy is discounted. I might have a video here that shows this dynamic load balancing in action. You ready for this one, Mark?
Mark left.
Oh, good. We got audio. So we got a site. This is without the dynamic load balancing. Got a certain amount of power. Software isn't talking to itself. All our chargers on our software are networked, so they all talk to each other. As soon as this thing guy pulls in, it's too much, he blows the brake. So we put in dynamic load balancing. It's software and hardware related. First guy pulls in, he gets his max charge. Second guy pulls in, he gets his max charge. And we suddenly start getting to a point where we've reached our capacity, and now the charge gets shared. The beauty here is that when these two guys finish, the other guys go back up automatically. The chargers are measuring each other constantly. They're testing against how much power is available to provide the maximum amount of power. So this does two things. It keeps the breakers from blowing, and it provides 6 cars worth rather than 3. More people can plug in and go do something else. So even though their charge may be reduced, there's usually a minimum stable.
It's annoying. Go in, no one's there, charge fully, some guy comes along and you get half the charge.
They're supposed to say the minimum on the sheet when they do that. That's supposed to be how the chargers are priced.
So just a question, more like a public policy. As we start to build out multiple public sites, how do we manage what I call charger hogs? Who
Charger what?
hogs.
Hogs.
Who park their car
And leave it.
And leave it. You know, they're fully charged and they're in the mall for 5.5. They're in the mall for 5.5 hours and there's no.
And the charge completes in 3 hours and they leave it there. So we use financial incentives. We hit them in the pocketbook. You get a text notification through our software that allows the person to know that they've got 30 minutes remaining until full, they've got 15 minutes remaining until full. They are full, they've got a 15-minute grace period, please come move your car.
Or
The parking meter will start running in 15 minutes at $1 a minute. Cool. And it'll run for the first 45 minutes at that rate, and then it will go to $2 a minute.
I like that. I'm not sure about the rest of the public, but I've observed that that's a real issue, especially in cities. Because you were talking putting some in Hoboken, and I frequent New York regularly, and I can tell you that's the same car parked there, and they are like they're just using it as a parking space for charging it. Kind of frustrating.
Well, at the parking garage, they don't mind that because they're in the business of charging for parking anyway. So for them, they're going to give the parking part for the charging session for free, included in the price. So they don't mind. So we just need a way to push those people out politely. But a lot of times,
I like that alternative. I'm not sure.
everybody needs to get in there. But the retailer has an incentive to have that guy stay too, because he's in there buying some more stuff. So the retailer might not want to push that guy out.
Right.
So you don't know whether it's the driver.
It's a discussion that has to happen as cities and towns continue to put in public charging stations or even the chamber. And then the next piece is on charging education. Some people get range anxiety, and as soon as their battery is like 2% below, they're jumping to a charger. whereas some people will run it all the way down. Is there, I've never, maybe it's out there, but I've never seen anything, education on how do you properly charge your battery? Is it better
Well,
to
you're
run the
about
battery?
to. I've got an answer for you coming right up. How's that?
Thank you.
This technology is in its infancy, electric cars,
Mhm.
right? We're emulating the distribution here of power, we're emulating what we're doing with gasoline. So instead of dispersing gasoline, we're dispersing electricity. We're asking a world, right, that we've given the iPhone, all these electronic devices to, whose lives have been accelerated. And we're giving them that technology, saying, slow down,
You gotta wait.
read the newspaper, right? This 5-hour trip from Manhattan to Cape Cod, 6 or 7, because you're gonna have to, without traffic, because you're gonna have to stop to get the car charged. What happens if battery technology gets to the point where we can pull into a charging station or whatever it's gonna be called, and we just take the batteries out, push them back in, it's a 10-minute, 15-minute exercise, and we're on our way. I mean, is the technology at the point where this is the future?
I think that
There is a car that does,
there's a like nice thing about a pack. You have a drill, you want to change the pack, and the other batteries on the charger, and you can just switch them. But when we get into the cars, they're very heavy, and you need like a cart with wheels and a lift to start changing them. So perhaps there could be components that were interchangeable. I think that the more likely thing that we'll see is that the battery components themselves, they won't come in and out of the car, but they'll become more efficient at receiving energy. So your 1 extra hour that you added to the trip will become half an hour only. And then it will become 15 minutes only. And then maybe the closer we get to 0, the slower the travel will be, diminishing marginal returns of charging battery technology. But I think that'll be the end solution. We'll still need powerful machines to dispense the energy, because we're going to want to be putting as much energy as possible in a short period of time.
On the human side of this, I'm watching the video and I'm seeing the cars getting, quote, split charge, but it's high enough that it meets they have an expectation. I'm gonna stop, I've figured out what I'm gonna do with my time, whether I'm gonna read or whatever. That changes when somebody else gets on that same chain. Their phone will tell them that the charging has slowed down. But as cars get added and the charging rate goes down, I had an appointment that I was going to catch. I even built in some delay, but I miscalculated because I didn't know how many cars were going to plug in. It seems like there's a whole expectation challenge there.
And that would be the case if there was no transparency in the delivery expectation. So we wouldn't on our chargers say, this is 180 kilowatts. We would say, this is 180 for a single charge, 90 split. There's also
You can sell
apps.
this $5 spatula on Amazon and compete with hundreds of other spatula sellers. You can sell digital.
Artificial intelligence.
We hit the volume button. So transparency there, so they have an app that's called PlugShare. PlugShare is, it's like everybody who has an EV signs onto it, you see every charging station gets linked into it. So I see every charging station that's active in real time. And you can go into it and there's customer reviews. And one of the things that people complain about when people aren't transparent is that stated charge versus delivered charge. So you can see in advance what the problem is. So other people who are complaining about the lack of transparency are providing accurate information for you, for your planning purposes, where it's not being provided intentionally. We recommend just being clear about how much there is.
Luther, what's the status of platform charging, where you can drive your car in, platform, and charge?
So this is new. They're trying to put it under the roads, and so you just drive right by, like when you put your phone on the table and it's charging automatically. Something feels uncertain to me about that, like there's gotta be some incredible amount of magnetism being emanated from that device that I don't wanna go near.
You don't want to sit in the car.
Yeah, I saw something on YouTube one day that the guy had an electrical tester, like a sniffer that was put in the circuits for active, and he walked into the power lines and held it up in the air and things started beeping. And it's like, I don't know, but I think there's something to don't live under the power lines. I think that the direct plug feels a little bit like it might have more safety, but maybe they've got some way to harness that or corral it, or collect it, or block it. It would be easier.
So they're already trying with the speed,
Mhm.
and Boston's in a certain route, they took a certain stretch of the street, they put the, whatever, the street, the buses go over it. The community, or be charged the buses, because they're trying.
Yeah, I think
There's
there's,
a shield between the battery and the passengers,
oh yeah,
so you don't have to worry about that.
that's from the battery to the passengers, or what about the road to the bikers? Or the walkers? Don't you?
I think it's in the middle of the road.
Yeah. Well, magnetism does decrease with the cube of the distance, as we learned in some shark experiments with fishing. So you have to be pretty close to a magnetism source, and you see the benefits of it.
There's some these expectations and raising expectations, but we're glad to hear, like last summer, I had a friend come and visit, they got an electric car, and I believe there was only one level of charging place in all of Cape, I think it was the mall.
Yeah.
And limited amount of charge, everything was level 1, so, in terms of this split load, there was no potential to even split that load, everybody's, everybody had, Cape is the lowest, your nurses lowest tier, so anything that we're doing, that you're doing, in terms of expanding the charging should hopefully help our expectations in terms of, like minimum policy with charging and accessibility for faster charging.
Yeah, we should check out that plug share, because it's kind of like, if you're looking at it like once a month, you can kind of see the velocity of the development of the chargers and the frequency with which new ones are being implemented.
Yeah, I think I looked at the resource thing last year, but I'm sure better this year.
What's the impact of larger vehicles, trucks, on the charging?
So pickup trucks can use this stuff. Once we get up to big rigs, Mack trucks, semis, trailers, they've got big battery capacity. And so we're working with a company called Zeem, Z-E-E-M. They've got a depot for trucks at a Los Angeles airport site. They are 5 megawatt site, and they've got basically souped up versions of those DC chargers that are able to deliver the higher end 500 kilowatts, which is 500 kilowatts in 1 hour of charge. And so it's the same thing, but bigger. And those fleets are electrified, but they have a bigger problem, which are, you can't just put one of those at Cumberland Farms. They need space to turn around and space to park and access to that electrical grid, because the farther we come from the source, the more expensive it is. So one of the projects that's being worked on right now in development and preliminary lease is in the port of New Jersey, close to the shipping ports. They want the trucks parked close to where the freight is so that they can be accessed by the port. It's like right across the street. So they're actually leasing it from the port of New Jersey. The port of New Jersey is understanding, like, if we have this on site, we're going to give up some of the real estate for this, because that's going to be such a need in the future.
Somebody else have something that we did?
I just wondered if OTEL had introduced any innovations for security. The very first chargers that we put up at the Yarmouth Senior Center were vandalized. Seniors were unfairly suspected, but and I realize the remote diagnostics let you know right away something's happening, but is there a way to keep it from happening?
I guess they could electrify them if we want to touch it.
I like the way you think, charge them and electrocute them, way to go.
So far, no. I don't even think that they have cameras on board of those things now, but I mean, I guess the site owner has some impetus to put security cameras out there. I mean, they are asking for lighting to be increased, and, you know, there was some theft going on. The people were stealing cables because they had copper in them. It's, you can't protect away from everything. I think it's just once it becomes a little bit more mainstream, maybe that'll get better.
Thank you.
Just kind of going back to the electrical distribution, if the number of electric cars just keeps increasing, at what point do we get where it puts a strain on the infrastructure?
12%. When the amount of cars reaches 12% of the total amount of cars, not the 12% that was sold last year,
Yeah.
the 12% mass adoption rate, our current will be tapped out.
It's not just that,
Bad
all the
answer.
semiconductor factories, battery factories are also very energy hungry.
Yes, so what we expect to happen is that rather than reach that bottleneck in however many years, the utilities and the battery development technology are working side by side to use battery energy storage as grid supplements. And they're bringing in solar components here that are tying in so that less of the electricity demand from the individual charging stations will be supplied from the grid main, but more closer, localized, supplied by solar.
Yeah, no, because I lived in Arizona, I had a Tesla, but I also had solar panels on the roof that signed 330 days a year, so I had way more I was generating way more electricity than with the home and the car. I was going back to the grid, right, so that's that.
Oh, we do.
So we are at 9 o'clock. So I know some people time this so they have other places to go at certain times. Steve, I know you have an appointment. You made that clear. But I just, you usually don't get kicked out of the room, so if we'd like to, continue to ask Luther some questions and have some discussion. This is absolutely fascinating, and it's relevant and necessary from all different levels, from the grid levels, from the institutional levels, and I know we have Aparna's here. She's from IT. But I'd like to hear a little bit about what the RTA is doing and how long it takes them to charge a bus and things like that. So, but anyway, I just, if we could just kind of wrap up and then keep it informal from now on. Is that good?
Oh, sure, yeah, I can so hang out. You just tell me, do we have a stop time where people can get up and go?
Well, why don't we let, so it's 9 o'clock now. If people have to leave, please go ahead, but you're welcome to stay and continue to have some interaction. Does that make sense? And I want to thank Luther. This is absolutely wonderful.